Okay, thanks, Connie, and good afternoon, everyone. Ken had asked me and allowed me basically an open-ended window to talk a little bit about some of the work that I've been doing in wheat production systems. So I've basically selected a few areas that I think might be pertinent today. One of the things that I like to start off with is just a reminder, and I use this slide as my illustration, that it's always important. Varieties are extremely important. Variety development is critical, and integrating new varieties, new genetics is sort of the foundation of your whole integrated system as a farmer. But we often lose sight of the fact that that provides roughly about 50% of your yield potential. And the other 50% is going to come from the production system within which that variety is grown. And so you can make a really old variety look actually fantastic with a very modern and up-to-date cropping system, or conversely, you can make some new genetics look pretty horrible if you're not doing things quite right in the field. And this is an example of that. We've got, this is just one variety, even though it looks like quite a few. It's just AC Lillian, and it's been subjected to varying rates of nitrogen and seeding rates. And as you can see, the things you set in place in spring will stay with you right through to harvest. So some of the things we'll touch on today relate to that. So what I thought might be pertinent today would be things like, out of interest, you're not going to go out and change seeders, I know, but it's always interesting to compare seeding systems in both spring and winter wheat. Seeding rates, a little bit of an update there. We've done quite a bit of work in winter wheat and spring wheat on nitrogen management, and had a look at some micronutrients as well as controlled release ureas and seed treatments. Okay, so comparing seeding systems. This was actually a study that I had set up to address managing sawfly, actually. And basically what we were doing is we were trying to kill sawflies, and so we were recropping onto spring wheat stubble that was infested with wheat stem sawflies. But it was also a good opportunity to compare different drills and pre-seed operations. So it was a two-factor experiment set up as a split plot where we had two different harrows, a heavy harrow, which you're probably familiar with, but something a little different in the way of a rotary harrow, and comparing those two to no harrowing at all. And then within each of those harrows, we either set it at quite an aggressive setting or kind of a moderate setting. And for our plot seeder, we have two different types. We have a Conservapack, which is now John Deere, I guess, basically the center wing out of a commercial Conservapack drill. And we've got two of those, one spaced at 9 inches apart, which is the 23 centimeter you see there, or at 12 inches, which is the 30 centimeter. And we also borrowed a drill that had John Deere disc openers on it as well, and comparing that to what would simulate chemical fallow of no seeding. And we did that both in a spring wheat and a winter wheat system. And so this is what the different things looked like. There's one of our plot seeders there. We also put on a knock-on sweep just to make it super aggressive. As you can see, that would make quite a mess going and recropping onto wheat stubble. There's that rotary harrow I mentioned, and the traditional heavy harrow, small scale, one of those as well. And so this is what the data looks like. And if you haven't seen one of my talks before, rather than just show you yield data, what I think is really critical to both you and me in our different roles is the whole idea of that system stability. So the y-axis here is your traditional grain yield data. But on this x-axis here, this is actually the variation observed in each of those different treatments. And so the bars here, then you create a mean here of your grain yield, which is this one, and then this vertical bar here is the mean variation of all those treatments combined. And so the ideal place you want to be, obviously, is up really high with your grain yield, but over as far to the left as you can be with variation, because you want consistent results. And so right up here is where you want to be in this box here. So the question is, what was good? And green, I would say, is good unless you like case or something. But in this case, for a spring wheat system, pre-seed heavy harrowing, at either a moderate or a tight tension worked the best, using either the ConservaPac 9-inch spacing or the 12-inch spacing in that regard. What didn't work so well, anything with SW that you see there is the knock-on sweep. Obviously that would create a lot of havoc and a lot of problems and inconsistencies. And the discs were a bit variable in the spring wheat system as well. Things changed quite a bit though in winter wheat. Obviously we really don't want to mess with that standing stubble all that much. We want to keep it up in standing to trap snow. So what happens? Well, less disturbance is better. So now we start seeing a lot of those Ds there, which is the disc drill coming up and providing above average yield, somewhat variable though. So for example, we had a good one here where no pre-seed harrowing with a disc drill. A little bit of harrowing provided similar results. Interestingly, the most consistent result on the winter wheat side was no pre-seed harrowing, but using the ConservaPac space 12 inches apart. So if we widened out that row spacing, we started to mitigate the results of that stubble disturbance that we were creating, for example, with the 9-inch row spacing, which was great for our spring wheat system, but as you can see here, not very good for a winter wheat system. Okay, so on to seeding rates and some nitrogen management work that we did. So this is a nice slide that I like to show, and I've been showing it for a long time, emphasizing why we are advocating for higher seeding rates in winter wheat. And 300 seeds per meter squared over here, which is around 30 seeds per square foot, you can actually get a very nice winter wheat stand and yield from that. But one part missing when you look at your yield data sometimes from one single year relates to things like weed management. So for example, as we increase our seeding rate here, we start seeing that canopy is starting to close up. And at 600, there's almost no sunlight penetrating that canopy. And when you have sunlight penetrating a canopy like you do in this 300, that's opportunity for wheat. And this slide kind of is a good illustration of that. On the y-axis here, we have grain yield data, and on the bottom x-axis here is our weed biomass accumulating in those various treatments. So for example, something like ptarmigan, which was a very competitive variety, almost irrespective of seeding rate, we were getting very high yield and lower weed biomass. But you can see even with this 300, the lowest plant population was creeping to the right of the others with more weed biomass. Same with Radiant, the highest seeding rate with Radiant over here, very low biomass compared to Radiant over here, seeded at a lower plant population. Falcon, and this is where you have a nice interaction too with variety selection and weed management and seeding rate. Sometimes if you have a weak competitor in the variety that you've chosen, you may encounter difficulties with weed management, and with a short variety like Falcon, you know, almost irrespective of seeding rates, we were having trouble with weed competitiveness, and not a huge surprise. So I know we like those shorter varieties, but that also comes with some difficulties at times trying to manage weeds compared to a taller, more competitive variety, likely seeded at moderate to higher seeding rates. So this was another study that I'd set up to look at sawfly management. At the time, that was probably the #1 production constraint back when I started my research program. But this was a good one and would be of value even if you don't have any sawfly problems at all, because the variety that we chose was Lillian. And if you don't know, for a CWRS variety, has, even outside of a sawfly environment, has very good yield potential. But more importantly, it carries the GPC gene, which is the gene for high protein content. So, and the third thing about it is that it has some very good stripe rust resistance. So growers are growing it irrespective of sawfly these days because of those two things related to protein and stripe rust. So what we did with Lillian is we planted it at, you know, a traditional nitrogen management factor of mid-row banding N, anywhere from 0 to 120 kilograms of N per hectare. The other thing we did, though, is at that 90 kilogram rate, we added a second treatment where we went in and did some in-crop foliar applications of a micronutrient blend called Yield Max. And I had used a micronutrient blend before, so we were concerned that we wanted to make sure to provide enough of that product so that we could see a response. And so what we did is we actually went in twice, and at each time applied 5 times the recommended rate. So we're at a 10x dose of this stuff on top of a 90 kilogram rate of mineral banded N. And then basically had it seeded at 3 different plant populations, ranging from low at 100 up to very high at 500 seeds per meter squared. Okay, and this is what the data looked like on this one. Sort of the good news with Lillian on the yield data was that almost anywhere from 60 to 120 N, kilograms of N per hectare was providing us with very high yield at those moderate seeding rates. And that was important because a solid stem variety can't be seeded at the same high rates that we want to seed hollow stem varieties. So that's the most we would ever want to seed a solid stem variety anywhere. And then the yield was bouncing around anywhere from 60 to 120. And of course, if you apply no N, which is this one, things don't work very well, and they really don't work well if you have a super high plant population. I circle these ones here because these are low plant populations giving super solid stems, but unfortunately that's providing us with consistently low grain yield, which is not a good thing. So definitely compromise required in terms of managing solid stem varieties. And this is a bit busy, but I wanted to show you this just because of the grain protein data, which was pretty cool. So as we add more plants to the field and they start competing for nutrients, it's not a big surprise that our protein would dip down a little bit, and that's what we see here. 14, roughly 14 for a low plant population, dipping down to almost 13.5 for the high plant population. What's even more interesting is when you go down on the nitrogen management side of things, and we had to go at least 60 kilograms of N per hectare to get to that 13.5, and actually jumping up quite nicely to 14.9 at 90 kilograms per hectare. And then, I mean, we're still climbing up at 120, but over here our yield is sort of leveling off. So that's something to start thinking about in terms of where we want to max out our nitrogen management. And these are the economics, crude economics around that. And so this top graph here are very high seed input costs, and Lillian was quite expensive when it first came out, and the fertilizer costs at the time of the study. And then the bottom one here is I've just increased the end input cost by 50% because it's so variable. But in both scenarios, that 90 kilograms per N hectare is giving us very good yield and providing us with the highest N returns in both scenarios. The 120 leveled off and actually starts to dip down if fertilizer costs go any higher than they were at the time. So the micronutrient blend data, and here we are here. As it turns out, with that 10x dose, we had no effect on grain yield, stem solidness, soft fly damage, or even protein. And you can see that from the data here. No significant difference with or without that micronutrient blend. Okay, so we wanted to have a look and compare both solid and hollow stem varieties at various seeding rates as well, just because we didn't have a very good range. We only had 3 levels of seeding rate in the previous study. So in this case, we were looking at Lillian, but also looking at a variety at the time, and even still so, I would say, CDC Go, which is from the University of Saskatchewan, very high yielding and quite a good competitor with weeds as well. And then Avonlea, an older Durham now, but with pretty good yield potential, and seeded at anywhere from 150 to 450 seeds per meter squared. And you can ask Ken Coles about this. This is quite truthfully day 1 of this study out at Brian Buckman's farm. And you can see the moisture conditions were fantastic that day. But Ken is resourceful, so he stole Brian's tractor and finished seeding that day. So yeah, thumbs up to you, buddy. And here's the data here. It was kind of surprising because I didn't really think spring wheat would respond to that high of a seeding rate, but in each case and across varieties, there was a very strong linear response to seeding rate through to that highest seeding rate of 450 seeds per meter squared. I thought it would be more quadratic and taper off, but as you can see, for example, Lillian, very nice, strong linear response Same with Go, and to the same extent with Lillian. But keeping in mind, this is where you have to sort of show some restraint with Lillian. If you want to have solid stems, you do not want to go any higher than this 250, 350 range, and be probably pulling back your nitrogen a little bit. Okay, so we've done a lot of work using controlled release ureas in winter wheat, and so we'll just show you a little bit of the data there. And we've had very good support of all of our industry stakeholders, from Western Ag doing some of the soil analysis for us, to Agrium and Agrium Advanced Technologies, Agritain, which is now Koch Agronomic Services, and the producer groups out of each of the 3 provinces as well, along with Ducks Unlimited. And this rolled into quite a large growing forward program related specifically to winter wheat agronomy that we hope we can continue moving into growing forward too. So in this case, we had 3 controlled release urea products or forms: ESN, Super U, which is a urease inhibitor, and a nitrification inhibitor. So basically, this is a souped up version of Agritain, which is strictly the urease inhibitor. And we compared that to just good old uncoated urea and nothing at all, no nitrogen at all. And so we took all of those forms, and we either banded it all at seeding, so that's with that Conservapac seeder in a sideband situation, or we did a split and we banded half of it and top dressed the other half in the spring, or we broadcast it all in the spring. And we did that for both radiant to milling type and that CDC ptarmigan, the soft white winter type. And sort of this is the shakeout of the yield data for that. And anything within that green box would be statistically the same. So as you can see, you've got a lot of options there with how you want to place your fertilizer, split it, and what kind of form you want to use. The Agritain products, particularly in a split, were looking very good. ESN all side banded was not different, but it was starting to dip down a little bit, and I think we've also done some work with ESN where the minute you're out of a seed place situation with ESN, which is by far the best product available for single shoot seed place systems, you should probably start blending it 50-50, because you won't find any difference related to yield or protein when it comes to either blending it 50-50 or just going with a 100% ESN. So your costs can be quite different without any real change to your agronomics. So what didn't work that great was our liquid. We actually used a liquid form at 2 sites, and that was without any stabilizer. And so we were clearly, looking at the yield data here, losing that either upwards or downwards. And the other thing that didn't look too good was ESN all spring broadcast in the spring, which is not a big surprise, and I don't think anybody in Agrium or anywhere else would recommend that you top dress with ESN. That plastic coating, if it got hung up high in that thatch layer, would probably not release as fast as you want it to. And in fact, that's probably our criticism of ESN, even on a side-banded situation. It's developed for the Corn Belt, and it frankly, in my mind, for the Northern Great Plains, doesn't release fast enough. And therefore, again, that recommendation that you should be blending it. Okay, so some yield data on this one. These NIT, that's Agritain. Urea, that's just regular uncoated urea. This SUP is Super U. And as you can see, splitting it was giving us very high and stable yield. A split of ESN was giving us high and stable yield. All side banding of Agritain, very stable yield. So a lot of options there in terms of forms and placements that'll give you very good results. What won't give you very good results is, again, the UANs as we had it set up, or things like ESN all broadcast. And again, that ESN all side banded is below average, as far as just below average for yield, and the reason, again, is probably that slow release. So on protein, what gave us good yield is something excuse me, that we're looking for in terms of protein. So things like the Super U all split, even urea all side banded, giving us very high grain yield and protein. Again, the UANs, another sort of reinforces the idea that we lost that. product because it did not give us yield, nor did it give us any protein. And this is just a quick thing to show you from another study where we also had a split application involving fall applications. There's interest, maybe not in southern Alberta or the southwestern prairies, but there is an interest to top dress later in the fall because it's more difficult to do it in the spring. And the problem, though, as you can see from this protein data, is you're clearly losing it or getting below average protein when you try to do that, as opposed to staggering that sometime in the spring. Super U did actually give us very good grain yield, and it was the only one that did with a fall split application. But as you can see, it still gave us below average protein, so I'm not convinced that's the way to go either. Okay, when we started that project with the most recent project with winter wheat, a big question related to seed treatments. Would they help or hinder stand establishment? There were some folks that thought it would delay it because it's a physical coating on that seed and it might, interfere with the water being imbibed and germination and so on. And there was, conversely, there were thoughts that it would actually speed up germination and give better stand establishment. So one of the experiments we did is we took and we built an agronomic system that would involve seeding rates, seed size, and that seed size would be a proxy for your seed lot vigor in my mind. So we basically took a regular seed lot of winter wheat and scalped it through a cleaner so that the heavy seeds were scalping off the top and the really thin ones were dropping through the bottom to give us 3 different seed lots that would vary in terms of vigor. And then we either treated it or we didn't. And in the treatment in this case was a dual fungicide insecticide provided by Beres, the Raxil WW. So as you can see from this picture, we did create quite a range of agronomic systems, from a low plant population with no seed treatment, with very thin seed or low vigor seed, to very strong agronomic system of high seeding rate, good seed lot, and a seed treatment. And so this upper left here is that poor agronomic system of low plant population, no seed treatment, and thin seed. And just by adding the Raxil to that system, you can see we made quite a difference in terms of how that stand looks and ultimately what kind of grain yield potential was centered around that system from just the seed treatment, which frankly was a surprise to me. I was a little bit skeptical of what role those seed treatments would play. The other interesting thing was if you go down to the bottom pictures here, we see, there might be an improvement, but the improvement isn't quite as stark as it is above. So that sort of reinforces the idea that the seed treatments might be a good insurance policy, but it still doesn't overcome the fact that you need to start with a strong agronomic system of a good seed lot and a good seeding rate. And so be sure that you're checking that seed vigor and germination of your seed lot, because that's the difference right there that can make. And so the yield data shakes out similar to what you see in the pictures, where we have things involving the seed treatment providing us with very good yield. For example, plump seeds, even at a low plant population, but with that seed treatment, gave us the highest grain yield here. What's interesting with that strong agronomic system is, though the picture didn't show clearly a big difference, what that did, though, by adding the seed treatment was move us to the left, which means that it gave us a lot more system stability across the 8 environments where we tested this. So that's something definitely to consider and not dismiss quite as easily. So again, the lowest one was that poor, thin seed, no seed treatment, low plant population. And what's interesting, by adding just the seed treatment to that one, that actually brought it up above average yield, but still a little bit variable, which is this one right here. The other thing that we ran in conjunction was a test that pulled apart the different chemistries that would form some of your seed treatments to see what is the mechanism behind that positive response to a seed treatment. And so we had no seed as one of our treatments, and we compared that to 2 fungicide-only seed treatments, an insecticide-only seed treatment, and then the regular combination insecticide-fungicide. The other thing that we did, which was really oddball that you would find, is that we went in the fall and we applied an in-crop foliar fungicide. In this case, it was Proline, just because it was a different chemistry than what we were doing up here. And these are the results from that, which you might find a little interesting. So basically with that fall foliar fungicide and the 3 different seed treatments of combinations or tebuconazole or the insecticide only, that gave us our best grain yield and our most consistent grain yield. What didn't give us very good grain yield, for example, was no seed treatment and no fall foliar fungicide. And you're probably thinking, what's going on with this fall foliar? And so here's part of the explanation here. At Lethbridge, Melfort, and Scott, when you look just at the fall foliar application, we had a significant increase in grain yield at all 3 sites. The difference was not significant at Scott, but overall it was still significant. And the reason for that was we had quite an outbreak of stripe rust in the fall of 2010. This is Melfort, and this is totally unheard of for Melfort, which is up in the north, sort of east part of Saskatchewan. We can get it from time to time, and this is the picture from the Farming Smarter site of it building up. What we didn't think was that a fall application would actually provide any sort of systemic control to give us any sort of a response in the spring. And what's even more interesting is the following year, even at sites where there was no stripe rust confirmed in the fall, what we saw was better vigor and cleaner canopy in the spring at sites like Lacombe and Brandon, and that actually related to the cleaner being less powdery mildew in sites that received fall fungicide. So we've got a little bit more work that we want to do and a few more questions we want to seek out in terms of what's behind that sort of response. The economics, the green here, the Raxil, would it pay for itself, and it clearly paid for itself in any of these protein scenarios, which is this here. The Raxil would only pay for itself combined with Proline in the fall for those sites that had confirmed stripe rust, at least so far in the study. Okay, so just wrapping up here, going back to the outline, the seeding systems work. The knife openers and heavy harrowing was much better in a spring system over a disc opener, so sorry for you disc guys out there, but good news for your knife guys out there. Highest yield observed with the disc opener in a winter wheat system, but surprisingly a more stable treatment was the wider space knife opener with no harrowing. So seeding rates, what should you be doing in my mind? Well, you should be around 300 seeds per meter squared if it's a solid stem system and you're trying to have a solid stem. If you don't care, then you can push those seeding rates, and if you have a hollow stem spring wheat variety, you should be pushing to around 400 in my mind for both yield potential and maximum competitive ability. And with winter wheat, you should be around 450 seeds, boosting that up a little bit to compensate for the overwintering. Again, my mind, the data that we had, 90 kilograms of N per hectare optimized both yield and protein. And the interesting thing about that is that if you do have a single shoot system or you want to place all your fertilizer at once close to your seed, you could actually do it all with ESN and forget about it, because 3x, which is the safe rate, 3 times the safe rate of uncoated urea, you'll get that kind of seed safety with ESN if you wanted to single shoot all of your requirements in one shot. Controlled release urea, there's, like the data shows, there's many options for that. You could band it all if you wanted to. You could incorporate Agritane or Super U as your top dress with urea side banding as an example. You could band your ESN and then, or as a blend and then put some Agritane on in the spring. Or again, you could blend it and put just regular urea as a top dress. So there's lots of options. And the seed treatment data thus far is looking very good in terms of grain yield improvements, but also as an insurance package or policy, particularly in those situations when you didn't seed it quite as early as you wanted to. You might not be going into the ideal stubble scenario that you thought you might be, those sorts of things. And with that, thank you very much.